Yeah, so welcome Jude. He's from Ethernet Sales and Enabling Team, belongs to Intel SMG. So why don't you take it from there and introduce yourself in a little bit more detail.
Okay. Thank you for giving me the chance to speak about Ethernet. And I know that this is the final session, and I'll make it really brief and to the point. I'm Julie, and I'm based in Santa Clara with a lot of these guys. And I'm working for a sales and marketing group for Ethernet sales enablement. Since it's going to be just a 30 minutes of presentation, I'm going to be really focusing on just two items, Ethernet market trend and Intel Ethernet product roadmap. Usually I have a longer slide rather than this one, and it includes the near future product roadmap. But I know that this is a session where we talk about the current product offerings in the market. So I'm going to just talk about what is available for the Intel Ethernet in the market. In the next few slides, I'm going to talk about Ethernet market trends. In the table, we have from 2016 up to 2020. And in the y-axis, you have the segment, Tier 1 cloud, big cloud service provider, and Tier 2, 3, which we call next wave cloud service provider, and enterprise. So we are at 2017, and if you look at the combination of 2017 and each segment, you can see and feel the difference. In the Tier 1 big cloud service provider, which is Facebook, Google, Amazon, they are adopting the higher speed, of course, and they are moving away from 40 gig to 25 gig and 50 gig. And we are seeing a lot of increased demand on 25 gig, especially from Tier 1 cloud big service provider. In the next wave, a Tier 2, 3 cloud service provider, there is some migration from 10 gig to 25 gig, and we are highly driving the market itself in next wave, a Tier 2, 3 cloud service provider from 10 gig to 25 gig. In the enterprise market, most of the enterprise market is still adopting 1 gig and 10 gig. Right now, currently the enterprise market, more than half of the Ethernet for the enterprise market is still with 1 gig. So the industry, consortium, and all the suppliers, including Intel, are trying to drive the enterprise market from 1 gig to 10 gig. And even up to 2021, for the enterprise market, we are expecting more than half of the enterprise market with a 10 gig. So right now in the enterprise market, we are, the mainstream for Ethernet is 1 gig and 10 gig, and we are experiencing the migration to 10 gig, and the 10 gig in the enterprise will be major speed for the Ethernet. If I speak more about 40 gig, right? 40 gig was a bigger trend a few years back for the Ethernet. But the big cloud service provider and the ecosystem are moving away from 40 gig to 25 gig. But if you look at the 40 gig very exactly, Tier 2, 3 cloud service provider and the enterprise are trying to adopt 40 gig this year and next year. So overall, the number of 40 gig ports will be declining. But if you look at Tier 2, 3, next wave cloud service provider and enterprise, 40 gig will be going up and picking up a little. In the next slide, after I talk more about the market trend, I'm going to touch more exactly about 25 gig. And yeah, so I'll talk about 25 gig in the next slide. this slide is made based on the data from the third party, Del Ora, and you can see that this data is based on Q3 and Q4 last year. And as I told you, most of the major speed of the Ethernet is still with 10 gig and 1 gig. And the majority of the market is 10 gig. In this 10 gig market, Intel has a commanding market segment share. So at the bottom left, you can see 3 years, 12 quarters of bar graph based on a 10 gig total LUM, the silicon controller, and the adapter MSS. And the blue line represents Intel. So you can see the phenomenal growth of Intel 10 gig in the market for the past 3 years. Exiting Q4 2016, Intel has achieved a 72% market segment share for 10 gig. So if you look at the 10 gig over TAM, we had a 15 million units of port last year, and analysts are expecting around 20 million ports for 2017. And out of 12 million ports, Intel is trying to maintain a decent volume as a market leader for 10 gig. I think this is the last slide about Ethernet market trend. And now we look at the higher speed, including 10 gig, 25 gig, 40 gig, and 50 gig. So as I told you, 10 gig will continue to grow, and we are seeing the increased demand, especially for 4x10 and 10G base T, copper cabling as well. In 40 gig, as I told you, the overall number of ports for 40 gig will be declining. But the rest of the market, including tier 2, 3 cloud service provider and enterprise, they are seeing the increased demand on the 40 gig. Now, future product of 25 and 50 gig. So in 2016, we had 240K ports for 25 gig in the market. And we are the industry consortium and all the suppliers are trying to ramp up 25 gig. And we are expecting 1 million number of ports for 2017 for 25 gig. So analysts were, very aggressive about 25 gig, but 25 gig volume didn't take place because it's not just about Ethernet, but you should have all the ecosystem and link partners in place. So there was some ecosystem immaturity and lack of readiness for 25 gig. So in the next slide, I'm going to talk about what is the difference between the IEEE and consortium, and how Intel has been ready to overcome this interoperability issue on 25 gig. So as you know well, in the Ethernet space, auto negotiation, AN, is pretty important. And moving on to higher speed, the consortium and industry are adopting more features like FEC, forward error correction, to correct the erroneous bit and flip them and correct them. Because so we have AN, auto negotiation, and FEC, forward error correction. And if you look at IEEE and consortium, AN is different. I mean, the AN standard regulated by IEEE and consortium is different. But if you look at the FEC standard, there's no difference between IEEE and the consortium. But consortium has been more generous, and consortium has been aiming to really move fast to a higher speed. And because of that, in the FEC side, we have base R FEC and RS FEC. RS FEC means Reed-Solomon FEC, and the consortium doesn't require RF spec to be mandatory. So it's a pretty optional based on the cabling. But IEEE requires both base RF spec and RF spec to be mandatory. And because of that, there's some, the gap and the difference between consortium and IEEE. But we are seeing the increased harmony between IEEE and consortium. And Intel has been working hard with industry, consortium, and IEEE to have our 25 gig NIC to be really ready in the ecosystem. So because of that, as you can see in the table, those switches are known to work, known to comply with Intel Ethernet solutions.
We have a question online. The person saying Tier 1 providers have more than 1 million of what exactly is their question?
Tier 1 cloud service.
I guess you said, so the question says Tier 1 providers have more than 1 million of what exactly?
Ports.
Ports.
Yeah,
okay.
Ports. Yep. So whenever we speak about Ethernet, we talk about the port. So in the Ethernet NIC, we have the bracket. In the bracket, we have the physical port. So in the physical port, you can have 2 serial lanes, 4 serial lanes, or 1 serial lanes, very ideally. So when we speak about the speed, in the previous slide, it's all based on the number of ports. So my talking point for this slide is that there is some difference between IEEE and consortium, and we have the spec to comply with the IEEE and consortium in terms of forward error correction and auto negotiation. But Intel 25 gig is complying with both consortium and industry, and these switches have been fully validated and are known to work with Intel 25 gig. This slide outlines the current available Intel adapter NIC in the market. So from Intel side, we are producing, as you can see, we call it NIC, Network Interface Card or adapter. It's a discrete NIC, discrete adapter. And aside from that, we have a discrete silicon, discrete controller that you can mount on your motherboard and do some system integration. So I'm just showing the Ethernet adapter in the market. And 500 series and the 700 series are 2 major series in Intel Ethernet. X520 in the far left is called the Niantic, and it's the highest selling 10 gig product in the market. And this X520 Niantic has been in the market already for 9 years. And it has been really stable, and it has been making the record shipment for these 9 years. X540 is called the Twin Pont, and it's based on the copper cabling, and it's the world's first single chip 10G based T with an integrated PHY device in the NIC. And the follow-on device of X540 is X550. And this is called Sedge Pond. So as I mentioned in the 10 gig market slide, X540 and X550 has been and will be the major 10 gig volume driver for Intel. In the 700 series, 700 series is called fourth field, and the 700 series we have 10 gig, as you can see in the black box. We have 10 gig and 40 gig, and we have another follow-on product from X550, which is a 10G based T for X710. So we have, for direct attach, we have 10 gig, 40 gig, and we have a 10 gig base T. And in addition to that, we have recently introduced a 25 gig, this one, XXB710. So this product is the focused product, and this product will be the foundation to move on to 100 gig and 200 gig in the future. And if I speak a little bit about the more higher speed that is not in the slide, we are already making a good progress to have 100 gig and 200 gig. So we are planning to introduce 100 gig maybe within 2 years. The next two slides outlines 25 gig details. So for the 25 gig, we have PCI Express 25 gig. The code name is called Harbor Channel, and the picture has 2 ports on the bracket. So this is a dual port, and in addition to dual port, we have a single port as well. So in the PCI Express, we have a dual port and single port for 25 gig. And in addition to PCI Express, we have OCP form factor single port card. So these three SKUs are available in the market for Intel 25 gig. And as you know well, these cards support PCI Gen 3, and it supports 10 gig and 25 gig as well. So if you buy our 25 gig, but if your cable is still 10 gig, then the link will be made based on the 10 gig speed. Okay, I think it was a very flyby, but this is the last slide. So Intel has been in the Ethernet industry for over 30 years. And from the number of ports that we have shipped in the market, it has exceeded more than 11 billion number of ports. So as you saw in the previous slide, we are the market leader in the 10 gig, and we have introduced 25 gig, and we have a good roadmap for the higher speed of more than 25 and 40 gig. So we will continue to this momentum, and we will drive the market. And the reason why Intel Ethernet is really preferred in the market is that, of course, we do a lot of validation, and our divisional engineering people are in Intel campus in Oregon State. And we have, extensive reliability and quality support resources. And of course, after we sell, we have, good customer support to have and provide us the continuous support about Intel Ethernet product.
What is the driver for 25 gig PCI based cards? Is it I40E, like all X7 cards?
Yeah, that's right. So if I, give you some more background, right? So Ethernet speed has been, jumped by 10x from 100 meg to 1 gig to 10 gig, right? From 10 gig to 100 gig, the people in the market saw 100 gig is a, big jump. It's kind of leap. So because of that, the market and the industry wanted to have some interim speed in between 10 gig and 100 gig. And once you have 10 gig and once you have 4x10, it becomes just a 40 gig, right? So Intel also drove the market to 40 gig. But as I mentioned, the big cloud service provider, they knew that ultimately the goal is to go to 100 gig and 200 gig, right? And to do that, they found that it's better to move on to 25 gig instead of 40 gig. So big cloud service provider now, they're, shifting away from 40 gig to 25 gig. And already, as you saw in the previous slide, we are having more and more of 100 gig compliant switches. And once you have 100 gig switching, then you have a 4x25 breakout cable from switch to NIC, right? So already we have a lot of cables, optics, and the switches ready, and those number of switches and cables, optics for 25 gig and 100 gig are picking up. So we see the clear trend for 25 gig, and of course the ultimate goal is to move on to 100 gig. Okay.
Chart hold true for the higher speed controllers and adapters?
Yes.
Is it the same chart?
Yes, that's right. So it includes both, as you see the top header line, it includes both the Ethernet controller and adapter. 40 gig? Oh, 40 gig. 40 gig. Yes, that's right. So this data was made based on the third-party data, Dell Aura, right? So there's a third-party data supplier for Ethernet, Dell Aura and Crayon. And I think those companies are meeting, on a regular basis with each of the Ethernet suppliers, including Intel. I saw them as well. So they provide their objective data for the Ethernet market. And they have really started to provide a 40 gig and 25 gig market data. So, but as I mentioned, 1 gig and 10 gig. If you just combine 1 gig and 10 gig, those account for around 95% of Ethernet port. So 25 gig and 40 gig is still too early, to judging, who is taking the lead in those speed markets. Mm-hmm.
Okay, we have another question online. The question is, what are the exact motivations to move to 100 gig, 200 gig, 100 gig, 200 gig for Tier 1?
So it's a similar question, I think. So yes. So a big cloud service provider, they have a lot of tiers in their servers, right? They have the data tier, they have a compute tier, they also have a storage tier. But moving on to the future, the data is exploding, and the big cloud service provider wants to have very optimized network in their servers. Generally speaking, their number of servers are expanding, but they will have their network infrastructure really optimized, right? And to achieve that, they already see that the higher speed is a must for network infrastructure. And as I told you, the market and the industry are moving away from 40 gig to 25 gig, so that it can be a stepping stone to move on to 100 and 200. Okay, thank you.
So the next thing we're